Hello, and welcome to Fireside Logic Chats. Today, we'll be going over sphere diagrams. These are an easy and effective way to communicate possibilities of alternate realities. Well, sort of.
Sphere models exist to model a really natural part of human conversation. You know, when you're sitting with a friend and you're like, well, if I did this, then this would probably happen. That is called a hypothetical conditional. So if I do something, then this will follow. And in terms of logic, that is an expression you can make an if-then statement. But there's a difference between an if-then that has happened and an if-then that might happen. And when we're talking about an if-then that might happen, it's helpful to be able to distinguish between realities that are closer to realities like our own versus hypothetical worlds that are really different from our own. So a great example of this is if I were to be holding a pen and I were to let go of it, then it would fall. And in most realities similar to our own, that would be true. If we only changed the fact that there was me holding a pen and I dropped it, and that was the difference in the reality versus me holding a pen and I don't drop it, those are very similar worlds. But if we had a world where I was holding a pen and I dropped it and it didn't fall, maybe because gravity doesn't exist in another alternate world, that world is going to be a lot more different than a world where the only difference is I actually let go of the pen. The point of a sphere model is to show that distinction, to show which worlds are more similar to our own world. Now, let's begin with what the symbols on the model mean. We'll start with a circle in the very center of our model, and this represents our world, reality as we know it. Next, we have our second world. So this is a hypothetical reality that is different in some way than our own reality, and is symbolized by the blue circle on the model. Next, we have a way to distinguish between the distance of various worlds. So we mentioned earlier that a world where a pen would fall is going to be more similar to our own than a world where a pen dropped won't fall because of no gravity. So the dashed lines that we're drawing are considered spheres, and they orbit the central main world, so reality as we know it, in an outwards direction. The spheres can be infinite in number or finite, completely varies and depends, but all of the worlds within each layer of the sphere are in equal closeness to our main world, reality, the red circle. Next, we're going to add a third world. This will be symbolized by the black dot in the top corner of our screen. And in a sphere model, you can have as many worlds as you like or feels relevant. But what's important to note about the black world here, or black circle, is it is outside of any sphere radiuses. So that means in this model, our spheres are finite. We don't have an infinite amount. And we have a world that's outside of the sphere. And essentially, all that's going to communicate for us is that that world is not in any relevant sense similar to our primary reality. Another way to think about it is it's so far, it's so different from our world that it's not considered to be close at all. So we have spheres and we have worlds. Red is reality. The other spheres around it are indicating how close or how similar various other worlds in our diagram or model are. And that brings us to the last element of our sphere modeling, which is to indicate for variables. So essentially what those mean is areas on our model where certain realities are true or false. So we can see, as is being depicted on our model now, the green section that's being drawn in is going to encapsulate some part of the model. And any worlds that land within that area on the model will be considered to have attribute A. So for our example, we're talking about if I were to drop a pen, if I were to let go of a pen, it would fall. So we can assign to variable A the first half of that sentence, if I were to let go of a pen. So that is A. And then the second half of the sentence we can express with variable B, saying, so if it were to be let go, then it would fall. So our variable B will be that the pen falls. And what we can do by expressing these variables as areas on our model is we can show worlds that have both attributes true, neither attributes true, and so on. So in our model, because I have not actually let go of the pen in reality, but we're just talking about it, we will find that our reality is within variable B, where things fall if they're dropped or let go of, but it is not within variable A, where I actually do drop the pen. However, our blue world, our closest possible world to our main reality, is within A and B. So that means at world blue is reality similar to our own, where I do in fact let go of the pen and it does drop. Lastly, let's learn how to write this. So in logic, if we're trying to say if something, then something else, and we have our variables A and B to represent if I let go of the pen, B, then it will drop. So we use an arrow to communicate that. And in this particular situation, we'll also add a box. So the box basically works to say that at this statement will be true if A then B, if it is true at all closest possible worlds to our reality.
So there you have it. Today we have learned all about the sphere model. Remember, this is us. This is the world where I drop my pen and gravity is real. And this is some world where pens don't drop and gravity also isn't real.